to talk about creational design patterns. And I would be using Java programming language to demonstrate those design patterns. The concepts that you would learn in this video, you could apply those to other programming languages as well. The creational design pattern means how you want to allow the object creation in your application. Design patterns is a common set of language that other programmers can learn very easily without you having to describe them, all the nitty gritty of your implementation in the code. So it helps in that part of the communication also with other programmers. They can understand your code very easily, they can understand your concepts. And also, it allows to make sure that your application is extensible and it does not lead into inconsistencies of object states because of you not following the design patterns correctly upfront. So there are these benefits that you would get with the design pattern. In this video, we're going to talk about the creational one, and in future videos, I would focus on other design patterns as well. So let's get started then. The first one that I would like to talk about is the singleton design pattern. This is the pattern that you would like to use when you want one object to be created of a particular class in the whole of the application. You do not want multiple objects to be created for that particular class throughout the application because you do not want unnecessary memory to be used. You do not want objects to be modified inconsistently in that case. And in those situations, you would use the singleton design pattern. And some examples where you would like to use singleton is that, say, for example, you have some database connection related information and you have a class for that, and you do not, there is no need for that detail to be modified within your application. Whatever you define as database connection, if that is something that is going to be the same throughout the application, you would have it in one class and you would allow only one object to be created for that class. If any code package within your application tries to create an object, it should ideally get the same instance which has been created by the application at any given point in time. The other example is that, if for example you have logger for your application, so the log information, or how you want to log the information for that application, should stay same irrespective of which module, which component you are in the application. So for such a use case, you would also like to have the singleton design pattern there. Similarly, the configuration settings for the application. The configuration settings, once you have them in the application, they shouldn't be changing from one module to another module. And for such a use case, you could have that done by a singleton class. In my example, say I'm building, say, a bike store type of application, a bicycle store type of application, and I have a store details class in which I'm storing some basic details about the store, that what is the name of the store, what is the location of the store, what is the manager name of the store. And this is going to be just same for the store, and my application scope is managing that store only. So for such a use case, I am having a private constructor here so that it cannot be the instance cannot be created outside of this class. So yeah, so now what happens is that when the class gets initialized, it creates an instance, and there is a method that I have which is which returns this particular instance. So whenever you call this method anywhere in my application, you would get the instance which is created when the class was initialized. There are other methods that you have here. So on the same object, you could run these methods and you would get this information that I have set up here. So that's my example for a singleton class. Now the code that I have here is to demonstrate that if I create an instance or get an instance from store details, is it the same one or different? So the reference that I would get from this statement, this print statement, and this print statement should be same. So let's just run it now. All right, so I have a lot of things going on in my program. But yeah, this is that statement which is printing the first instance here. After hello, we are using singleton pattern. This and the next one, the address there is the same, which tells us that the instance was not created again. So that's the beauty of singleton design pattern. Now let's move on to the next interesting design pattern. Let's say I have a class again for my bicycle store management application. I have this bicycle class and I have certain properties for this class. I have a constructor which takes in all the properties and sets that those properties for that particular object. And you know that this is a basic class that I have. Now, very simple. If I want to create an object, I would just do the class type, name of the object, and I would call the abstract constructor with the new keyword, and I would get a bicycle object. Now, supposedly, I want to add one more attribute. The changes are something that you would always receive, and say you also want to capture another attribute for your cycles, say material. Now, for creating objects, you would have to add, modify the constructor. You would have to add the parameter here, and you would also have to initialize it with the values that you are getting from the code that is trying to create the object. So now you would see that you would start getting errors here because the attribute that you have added, there is no option for you to set that parameter as optional. So wherever in the code you have created objects of bicycle, you would have to provide one more attribute for those uh, code paths to execute successfully. Imagine doing this for a lot of other parameters. As you learn, you modify the class. You again go to the code where you are creating those objects. You would have to modify them again. And one naive way is that you could have multiple constructors. You would do method overloading, but you can't keep doing that for a very long time. There has to be a better way of doing that, and there is. So let me just take away this for now, and let me just explain you the builder pattern that takes care of this problem. So now the error goes away as you would expect, and you would be able to print the cycle brand, which is one of the properties here. Now the builder pattern. The builder pattern solves the problem that I was just highlighting. And how does it solve the problem? It solves the problem by having all these properties here, like the brand, size, cost, as properties of this bicycle builder, which is the builder class for bicycle. And then, I have a few methods. I will talk about create electric and create city later on, but let's just focus on create bicycle. Here it return new bicycle with these properties, and you have now the flexibility to set the properties of the bicycle builder, whatever property that you are looking forward to set, and other properties you can just ignore. Let's just go back to my main class, like for example. So here I have the bicycle builder, and I'm just setting up the brand here. I'm setting it up to my favorite brand, REI, and now I just call create bicycle. I'm not at all bothered about setting up size, cost, color, type, and so on and so forth. And I could just do it. Now, if for example the material thing that I was highlighting, if I have to do it in this setup, I would make a change in bicycle. I would change I would make a change in bicycle builder, but none of the other code which was creating the objects has to change. Wherever I have to use material, I would just call cycle builder dot set material as whatever it is, and I would be able to make use of it. So it gives you that backward compatibility without doing a lot of things to maintain that. And that makes that your code is extensible. You can move with a faster pace without worrying about what would happen to the previous code, because when you are adding newer functionality, you might be needing that for newer objects and not so much for older implementations. Okay, great. So now that's how the builder design pattern solves a very big problem for you. Yeah, and I have created electric bicycle and city bicycles, which are subclasses to bicycle, and I have respective methods within the bicycle builder class to also give objects for subclasses. But yeah, explaining bicycle builder, I think up until this point itself was good enough. So yeah, you can run it, and you would see that up here you would see the brand as Trek, and then you would see brand as REI. That tells you that you were able to successfully create a bicycle object without having to worry about setting up all other properties. So it's already run the previous iteration. So this is where it says Track. This is where it is REI. So it tells you that you can create objects without having to worry about a lot of parameters that you would have in the base class. Yeah. Okay. Let's move on to another design pattern, which is also very interesting, and this is called as factory pattern. This is where you need to decide on object representation based on certain rules. And let me give you an example here. Now, you have some business logic and you say that, oh, I want an electric type of bicycle object. So, you do that, you create a bicycle object, OBJ bicycle factory, create cycle, you're providing type as electric here. And this is my factory, bicycle factory implementation, where I'm taking type and I have a switch statement here, which looks at that, oh, this guy is talking about electric. Let me give back electric object. So this makes object creation very easy. And if you have situations where your interface or abstract class is going to change frequently, and if you would have created the concrete objects directly through, say, bicycle or busy cycle is equal to new electric cycle, and you have certain parameters there. So it makes life difficult because certain things might change for in the constructor, and you would have to keep correcting that, keep updating that. Now in this case, you don't have to do that wherever you have created objects. You would only have to do in the bicycle factory. So in this case, if there is any change in, say, create city bicycle, I'm using the builder also within the factory, which makes it more easy. But even if I'm creating a new object right here, I would have to make a change here and not in the clients where I'm creating those objects. So that's it. So we looked at three design patterns. They are for the creational phase for your application. I hope you like the video, and if you have any questions, do let me know, and I would try to get back to you.